Today we will learn about triangle inequalities. When you are given a side, just the sides, there's actually a way to figure out the order of the angles from smallest to largest. If you are given two sides of a triangle that's not congruent, meaning all three sides have to be different. The big side lies opposite the big angle, and the small side lies opposite the small angle. So, I already have my answers filled in. Let me go ahead and explain them. On my triangle, I have a 34, a 46, and a 37. My biggest side is that 46, that's side AC. So opposite it, across from 46, is angle B. So my biggest angle has to be angle B. My smallest side is 34, so across that, my smallest angle has to be angle C. There's another trick to figuring out which side goes with which angle. So from the picture, sometimes it's easy to tell. Okay, 46 is across from B. But sometimes it gets harder to tell. This is triangle ABC. So if you look at side AC, compare AC with ABC, you're missing the letter B. That means AC is opposite B. Side BC, you're missing the letter A. So side BC is opposite angle A. Side AB, you're missing C, so side AB is opposite angle C. AB, opposite angle C. So here's some examples. 1A, my biggest side is 80, so opposite that, my biggest side is 82, didn't see that. Biggest side is 82, so opposite that is A. My middle side is 80. Opposite that, B is my middle angle. My smallest side is 75, so opposite that, my smallest angle is C. Over here, we can tell that E has to be the biggest angle because if you think back to properties of a triangle, there can only be one obtuse angle in a triangle. So if this is obtuse, that means the other two have to be acute. In other words, if this angle is bigger than 90, the other two have to be less than 90. So this is my biggest angle, angle E. Next, between the 12 and the 16, 16 is my next side. 16 is opposite D, and 12 is my smallest, it's opposite F. Part C, when you're given a problem like this, my advice is to draw a picture. So it has triangle JKL, so I draw a triangle and I just go clockwise, JKL. JK is 8, KL is 5, JL is 7. So biggest is 8, across that is L, biggest is 5, middle is 7, across that is K, smallest is 5, across that is J. Or using my alphabet trick, biggest is 8, JK is 8, JK is missing L, so JK goes with L. My middle is 7, which is JL. JL is missing K, so JL goes with K. And KL is 5, KL, it's missing the letter J from JKL, so KL goes with angle J. So if you have sides, you can figure out angles from smallest to biggest. The converse is true. If you are given angles, you can figure out sides from smallest to biggest. If two angles of a triangle are not congruent, then the following is true. The big angle lies opposite of the big side, and the small angle lies opposite of the small side. So in my example over here, my biggest angle is 75 degrees, angle C. So opposite C is AB. AB has to be the biggest side. My middle angle is 58. So opposite angle B is side AC. My middle side has to be side AC. My smallest angle is angle A, 47 degrees. So my smallest side has to be side BC. Alright, over here to the example. So when you see something like this, my first idea is we need to figure out all my angles if we can. I know this is 54, I know that's 74. We can figure out B. 54 plus 74 gets me 128. Because all three angles add up to 180, we can do 180 minus 128. Got me 52. So this is 52 degrees. Now we can see from largest to smallest, my largest is 74 degrees, which is opposite side AB. Middle is 54, which is across from BC. And smallest is 52, which is across from AC. So this is a good example of go by what the numbers look like and not what the picture looks like. Because the picture looks like B is a pretty big angle. But if we were to actually fill in the numbers, you'd find out that B is the smallest angle, which makes AC the smallest side. Next up, again, fill in the angles if we know them. Right here's 114. This side and this angle are a linear pair. Linear pair means they add up to 180, so 180 minus 114 gets me 66 degrees. Now I know 66, I know 35. We can find out the top angle. 35 plus 66 gets me 101 degrees. All three angles add up to 180, so I can do 180 minus 101 to get me 79 degrees. So now I know my biggest angle is M, opposite M is RQ. My middle angle is R. So from my alphabet of MRQ, angle R, we're missing MQ. So it goes with MQ. And last is Q, so that goes with MR. Okay. Last example. We have letters, we have angles. Let's go ahead and draw a picture. Again, we go by what the numbers tell us and not by what the picture looks like, because your picture isn't going to look anywhere near accurate if you just make a quick sketch. Like this. E is supposed to be 112 degrees. In my sketch, it doesn't look like an obtuse angle. So we go by the numbers. E is the biggest angle, so opposite that. DF is the biggest side. Next, 37, which goes with EF. And last, 31, which goes with DE. So whether you're given sides and you're looking for biggest angle, smallest angle, or you're given the angles and you're looking for biggest side, smallest side, it's always the rule that the big side goes with the big angle, the big side's opposite the big angle, and the small side is opposite the small angle. Alright. Next part, for triangle inequality, the actual triangle inequality, is if you are given 3 side lengths, can we figure out if those 3 side lengths will make a triangle? So, here's one example. If I have one length is 11.5, the other is 7, and the other is 5.5. Can I take these 3 side lengths and form a triangle? Alright, so let's write my example here. 5.5, 7, 11.5. And yes, I actually measured these out to prove my point. So we can physically see that, yes, if I put their corners together and slowly close up my triangle, they're going to touch. It makes a triangle. So yes, it makes a triangle. What if instead we have these 3 numbers, a 4.5, a 7, and an 11.5. Right now, I can tell you right away, this is not going to make a triangle. So, if I try to slowly close it, I can close it all the way down. It collapses on itself. That's not a triangle anymore. So that's a no. And one last example, if I pick these two, these numbers, put them on the corners, see if we can close it to make a triangle. That's too far, so that's also a no. So the trick here is the sum of the lengths of any two sides of a triangle is greater than the length of the third side. A plus B should be bigger than C, greater than C. So here's my examples. I'm going to do one example. After I do one example, I suggest that you pause the video and see if you can solve for B, C, and D. So I always want to pick, over here it says the sum of the lengths of any two sides needs to be greater than the third. That's the theorem. If you're just testing it, as long as you always pick the two smaller sides and compare it with the biggest side, then you're good. So my two smaller sides is 1 and 3. So 1 plus 3, and we're going to ask, is that bigger than 6, greater than 6? 4 greater than 6, that's a no. So this cannot make a triangle. So go ahead and pause this video and see if you can do B, C, and D. Alright, for B, the two smaller sides 11 and 12. 11 plus 12, is that greater than 15? Is 23 greater than 15? The answer is yes, so that does make a triangle if those are side lengths. Right here, the middle side and the biggest side happen to be the same, but that's okay, the rule still applies. The smallest side plus the next smallest side, is it greater than the biggest side? 9 greater than 8, that's a yes. Last one, be careful on this. I see, most common mistake I see are students wanting to add 5 plus 9 because it's the first two numbers they see. Don't. It's always the two smallest sides. So we have a 4 plus 5, and is 4 plus 5 greater than 9? 9 greater than 9, they end up being the same. That's a no, because it has to be greater. So going back to my relationship, what we were comparing is 5.5 plus 7 bigger than 11.5. Is 4.5 plus 7 bigger than 11.5. Okay. The reason it has to be greater and not equal, like in D, is going back to my popsicle sticks right here. 4.5 plus 7, you can see that these two are the same. 4.5 plus 7 does equal 11.5. And if they're equal, and you try to make that triangle, it ends up collapsing on itself. It goes on top of itself. So that's not a triangle. It needs to be slightly bigger so that it opens up. Alright? We can extend the triangle inequality theorem. If given just two sides, like in my example, all I know is 8 and 12, where side A, one of them is smaller than side B, then the length for the third side can be represented by the following inequality. Minus A less than C less than B plus A. What this means is, if you are given two sides, how the possible answers for the third side have to be between this inequality. So let's do A as an example. It's always the bigger minus the smaller. 12 minus 8 is 4. That's what B minus A means. And 12 plus 8 is 20. B plus A. So your third side for it to make a triangle has to be between 4 and 20. If you're given 8 and 12 and your third side is 3, then no, that's too short. If your third side is 21, then no, your third side is too long. Those cannot make a triangle. If you want to make a triangle with 8 and 12, then your third number has to be a number somewhere in between 4 and 20. 4 less than C less than 20. So go ahead and take a few minutes to do B and C. Pause this video if you have to. Alright, 16 minus 5 is 11. 16 plus 5 is 21. That tells me my third side has to be between 21 and 11. And for C, we have 23 minus 18, which is 5, and 23 plus 18, which is 41, which means my third side, side C, has to be between 41 and 5. So there you have triangle inequality. Two key things: that your two smaller sides need to be bigger than the third for it to make a triangle, and that if you're given two sides, we can figure out the range of possible sides for my third number.